So we were talking about what the solar wind from the sun and the light from the sun does to the melt that's coming off of a comet. And I have it summarized for you here before I go on. So comet tails and the solar wind. Two things happen. One is just the light from the sun just pushes the melt. It causes it to melt in the first place because the light is associated with heat, and then once it's off, when the photon collides with the melt, it pushes it out in the direction that the light was originally traveling. And the solar wind, which we also know is present from the sun, pushes the melt also, but also causes it to glow blue a little bit. Okay, so if you can remember those two things, the sun causes two things to happen to the tail. Both sort of get pushed away in the direction that the sun's rays, light rays and solar wind were traveling, but there's also some glowing and some pushing going on. Okay, so we go back over here. We go back to our story here. Remember, we're trying to get an answer to the question is, can you tell a comet's direction of travel based on the picture of it alone? Okay, well, what happens here is certainly when the comet is getting close enough to the sun, say here a little bit, and here's some more. Let's just go with this picture right here. We're getting this melt. Then, of course, the effects that we're going to see are we will get the white comet melt that is sort of having drawn in here already. We will get that coming off. But, of course, also we know now the effects of the solar wind. We're also going to get this bluish stuff coming off too. Blue is going to be in there too because that's what the solar wind does to the comet's tail. But you have to draw it in there very carefully in order to get this effect going to describe what we actually see. So let me draw the comet in a new position right there. And so the one thing that you'll definitely draw is that when light comes off the sun, it sort of travels radially away from the sun, something like in this direction like that. And so that's also going to correspond to the direction of the melt, because the melt just follows the push of the light from the sun. So the melt is sort of going to be directly backwards that way as well. Now, the solar wind is coming off the sun in a similar direction. So let's just say the positive charges coming off the sun and the solar wind sort of go in the same direction like that, just directly out. And so you will get then the bluish tail in there also, something like that. Okay, so let me just pause there for a minute, and hopefully you see the two effects that are here. One effect is coming from the light, the other effect is coming from the solar wind. That's so the positive charge there, the solar wind, which we know the sun bathes the entire solar system in. So if I go back just a tad bit here to some of the comments that I showed you very early, here it is. That's likely what's happening right here in this particular comet. You see the bluish tail, that's the action of the solar wind pushing on the melt and causing it to glow. And you see the whitish tail here, which is strictly the melt and the sunlight the comet's tail getting pushed by the sunlight, okay? And so what starts to happen when the comets the tails start to separate and they look really distinct like that is starts to happen then is, back up here, is that as the comet starts to get a little closer to the sun, the melt gets more intense. And what will happen is it's not like this melt disappears here, but I'll go ahead and draw the comet maybe getting really close like this. And some of this melt here is going to still be visible. That's where the comet used to be. So I'll sort of draw that in here a little bit. But of course, now the comet is getting a little bit closer to the sun. And again, you'll sort of get this push away. The melt gets pushed away like that. And there's still some melt left where the comet used to be. So it sort of the tail might start sort of looking like that, So definitely for sure, the new melt is in the same direction as the light coming directly off the sun like this, straight along this line. But this is where the comet used to be, and that's in there as well. Now, the bluish light that comes from the solar wind never has anything to do with where the comet used to be. That's more of an instantaneous effect. So if I draw this black line sort of coming out like this, let's say that's the direction that the solar wind is traveling on like that. And if that's true, the solar wind coming directly away from the sun like that, then wouldn't it make sense to you that that's where the bluish part of the melt is going to be, like that? That's where the bluish part of the melt is going to be, something like that. So I'm giving you a very rough picture here, and exactly like there wouldn't be maybe that big of a separation between the solar wind effects and the melt in here because they're both coming directly off the sun. But at least in the sketch that I've drawn there, I think I've done a pretty decent job, at least in this sketch right here, of maybe showing you how a comet could possibly come and look like this one right here. So here's the whitish melt getting pushed by the sun's light. Maybe it's curving just a little bit where the comet used to be. And here's the direction that's coming right off of the solar wind here, off of the sun. Okay, so I'll keep going back then, and let's see if we can wrap it up now and get the answer to that question about what direction is the comet traveling from the tail alone. So I think I'm about running out of time in this video. I'll pick it up in the very next one.